The last video looked at modification of the variation of the exponential function a b to the x, and we found that it could be expressed as y is equal to a times 1 plus r all to the x. And that's fine, and we know r is the decimal corresponding to the percent change, and so that all made sense. Now, we can actually refine this a little bit further when we're looking at a specific application when it comes to finances. So typically banking, but maybe you're working with a different financial institution, such as a high yield savings or some long-term investments like an IRA, Roth IRA, CDs, that sort of thing. And so when you're working in the context of money, okay, this interpretation shifts a little bit, okay? In this model, y is equal to a times 1 plus r to the x, right? Y would certainly be, your money. Okay, that's the important thing. Okay, and then x is typically expressed as, time in years. Okay. Now, what gets tricky is in the context of the banking or other financial situations, the R value is viewed a little bit differently, okay? R in those situations is viewed as your period rate, okay? And so how this is calculated is banks offer, you might have seen it before, APR, annual percentage rate, okay? But again, that's annually, so right now a good one, at least for high yield savings, is about 4%. And what you do to get your period rate is you take your APR and divide it by N, which is the number of times the amount is number of times compounded in a year. Okay, so and the term compounded, hang on, let me write this out, compounded in a year. Okay, the term compounded just means that's how frequently the amount of interest is assessed. Is it if you're compounding quarterly, that means you're assessed 4 times a year, so every 3 months. Maybe sometimes interest is assessed monthly, so that would be 12 times per year. And semi-annually would be, and twice annually, it would be 2 times. So that the number of times that it's compounded in a year is dependent on the financial institution and the account that you set up. Okay, so that N is variable, but R, point being, R is viewed a little bit differently in the context of finances. Okay, so when we look at our compounding equation, our equation to determine the amount or the value of a financial investment at a certain time N, or a certain time in the future, you would still have 1 plus R, which is the APR over N. Okay, so the annual percentage rate divided by the number of times it's compounded. And then the only other change is in the exponent. It becomes N times X. Okay, and the reason for this is that the time, right, this is time in, time in years, right? But when we look at R, that's assessed some number of times in a year. So we have to multiply N or X times whatever N is to determine, what its value will be at the end of a year, because it's accrued value at certain regular intervals during the intervals of time during the year. Okay, so this is our compound interest formula. Okay, and again, just so we're clear, A would still be your starting amount, also called the principal. Okay, so we're going to use that as we look at an example. Okay, so typical savings accounts, okay, it's just a typical savings account right now, terrible interest rate, compounded quarterly. So if we put $10,000 in, okay, so I'm just going to start identifying this. So A would be the amount that we start with, so $10,000. Okay, and then we know that it has an APR of 0.5%, so that's 0.005, okay? Careful with your zeros, converting the percentage to a decimal. And then we said it's compounded quarterly, so that means n is 4, okay? And then this is all to the n times x, which x is the number of years, okay? So then if I look at the value of the account in 10 years, I would do y is equal to 10,000 times 1 plus 0.05. Nope, that is 5%. I want 0.5%. All raised to the 4 times 10, also known as 40. Okay, and if I calculate this at $10,512.38. Okay, so 10 years with this abysmal interest rate gets me a whopping $500 in interest, okay? And interest would just be how much you gain in comparison to how much you started with, okay? So that is not great. I would look for a different account to put your money in myself. But there we go. So the big idea is we had to identify our principal, right? And then we had to identify our APR rate. And then finally, how many times we're compounding each year, okay? If we're optimistic, so in the case of, putting our money into an account to have it grow its value, or if you're really pessimistic and you have a mortgage or a loan and you're saying, oh, they could compound, they could assess interest continuously, so like every minute of every day of every second of your life, right? You could get an interest rate where it's compounded continuously versus say 4 times a year or 12 times a year in the case of monthly. Okay, in that case our model shifts, and it shifts to be A0. So this is just in terms of the notation. A0 is still your principal. Okay, previously we called this just A, and then e to the RT takes the place of b to the t, or the 1 plus r to the t. And so r is just your rate, again, as a decimal. Okay, and actually in this case, it is just your APR. Okay, and then t would still be your time in years. Okay, so a little change in notation, but same overall idea. Okay, so if we're looking for the amount of your savings account, so you'd still have the $10,000 that you invest in this case, and then you'd have E, and then the interest rate would be still that 0.05%. So I didn't provide that detail here, but it's the same savings account that we were working with above, and then T would just be your variable instead of X. Okay, and so now if I'm looking for the value of this account after 10 years, I would still do 10,000 e to the 0.005 rather times 10. And now if I substitute this in my calculator, so you might have to find where the E button is, but the other big thing that students miss is that the entire exponent has to be in parentheses. So just be careful when you're doing that calculation on your calculator. But when I do that on my calculator, I get, okay, 0.005 times 10, all in parentheses. I get, let's see, not 5. I get $10,512.71. Okay, so did I make more money? Barely. Okay, and this is mainly due to the terrible interest rate that you have. But point being that the continuous model, compounding continuously, is kind of the extreme case where you could earn or be assessed that interest rate every second of every minute of every day in comparison to a certain number of times a year. Okay, so be aware of these two models as you work through in situations where you're compounding money. If it's the case where it's some number of times, we have to use the model where it's APR over N. if you're compounding continuously, that's where we have to use the e to the RT model.